Let's now calculate the moment of inertia of a solid cone which is rotating about a central axis which is passing through the center of its base and along the altitude of cylinder. In this situation, as being a rigid body, we first need to consider an element. For the solid cone, we'll consider an elemental disk at a depth x below the vertex of cone and say the disk is of width dx. Say if small r is the radius of this disk, this radius we can calculate by using similarity as small r by x is equals to capital R by h. So here we get the radius of this elemental disk as r by h into x. Now in this situation for this elemental disk, if we integrate it from x equal to 0 to h, we'll get the complete cone. So first we'll calculate the mass of this elemental disk. If we just calculate this, we can consider as dm, which can be written as mass per unit volume of the cone. If its total mass is m, mass per unit volume multiplied by the volume occupied by the element. So here it will be m upon the volume is 1 by 3 pi r square h. Well, multiplied with the volume occupied by the elemental disk, which can be given by the product of surface area and its height, which can be written as pi r squared dx. So in this situation, if we just substitute the values of small r, the radius of this disk, we'll get this dm as 3m by pi r square h multiplied by pi. Small r square will be r square by h square into x square dx. Here this r square gets cancelled out, pi also gets cancelled out. So this elemental mass we can write as 3m upon h cube into x square dx. Now for a given disk, we know that the moment of inertia of a disk can be written as half mr square. So here moment of inertia of the elemental disk is, this can be given as di, which is half dm small r square, which is the moment of inertia of this disk, on integrating which we'll get the moment of inertia of cone. We substitute the values of dm and r over here. We get this di is equals to half 3m by h cube into x square dx multiplied by r square is r square by h square into x square. Now in this situation, total moment of inertia can be given as integration of di, and this will be 3 by 2 m by h to power 5 into r square into x4 dx. Here we just keep all the constants out of the sign of integration and we integrate this x from 0 to h. So we know the integration of x to power 4 can be written as x to power 5 by 5. So this will become 3 by 2 m by h to power 5 into r square, and as x to power 5 by 5 we apply limits from 0 to h. So this will be h to power 5 by 5 minus 0. So here we'll be getting 3 by 2 mr square upon h to power 5 into h to power 5 by 5. This gets cancelled out and the result we'll be getting is 3 by 10 mr square. This is the result for moment of inertia of a solid cone about its central axis.